Okay, so the very next video is this. We're going to now calculate our radius. So we're just going to say, instead of us trying to do everything at one time, I'll just make this a bit smaller here. We know that our radius is somewhat formidable, but we're just going to take this bit by bit. We're going to do b over 2p, and then we'll do b over 2p squared, and then we'll do the other part, 9 times eta times the fall velocity over 2 times gravity times the density of oil. And then we can put it all back together. So let's approach it like that. So this is B divided by 2. And I probably should do it this way, 2P. Okay? So this is just going to equal to, and let's go find B. B is already calculated. And then we want to divide it by 2 times P. And we have P right here. And we're going to just hit return. All right, so we have B divided by 2P. Now we can just do that same thing and we can square it, okay? So I can just bring this down and then say fill, drag this over, and put some parentheses around it. And all we're going to do is just square this. So all I'm doing is taking what we've calculated already, and I'm going to square it. Why am I doing that? Well, if you go back to the equation here, we'll see we have b over 2p squared. We also have b over 2p on the outside here. So the next thing that we want to calculate will be 9 eta VF. Make sure I have everything in there. Okay, that's good. Uh-oh. So this is going to be 9 times eta times the fall velocity. All right. So we can do this fairly quickly. You say 9 times, need to put an equal sign in there, 9 times, and what do we have? We have eta times our fall speed, fall velocity, and then that calculation is actually done. And the last thing that we'll need as far as what's in this equation is here. It's 2 times g times rho. So let's just go ahead and do that. 2g and then output times rho. Okay, for whatever reason I'm not able to put, well, I'm not putting those mathematical symbols in, or those Greek symbols. So this is going to equal to 2 times, and we have g, we already put it in here, gravity, times the density of oil. All right. So this is the information that we're going to need, and I'll just give it a green for go. All right, and all of this is based on what we did before. So now we can actually calculate our radius. And the radius is just going to equal to the square root SQRT of, remember, we have b over 2p squared. So our b over 2p squared is right here. And then that is going to be plus, see, b over 2p squared plus, and I'll just put these in, well, it doesn't matter, plus our 9 eta VF divided by 2g rho, okay? And so that square root is done. And now we're going to have minus, and I'll just slide over so you can see that. So that's all in the square root. Now we're going to say minus b over 2p. And this should give us our radius, minus b over 2p. Uh-oh. Excel cannot calculate formula. What happened? Let's see, it's possible that I put in, let me double check. Let me just clear that. And again, let me call this the radius. And this is going to equal to SQRT. Select that formula, and then we're going to have B2 minus eta, 9 eta VF divided by 2G rho, and then we're just going to close that parenthesis, and I'll hit return. I think when I put in, it must be the fall velocity. Oh, let me go back. Oh, it's supposed to be a plus sign in there. Let's see here. Return. So it's saying 0 right now, and that is going to be minus our b over 2p, and just return. And they're giving us a radius, and I'm not quite sure why this is negative and why it even looks like this. This is very, very small. Oh my gosh, look at the formula. All right, that's more like it. It's still kind of big, but still, it's 2.29 microns. So the radius is in meters. And we want to make sure that this has some distinct color, and let's just call this, just make it rust or orange looking. So that's the radius. The next thing that we will calculate is going to be our mass. Okay.